Okay, good evening. Welcome to
MinuteMath number 103.
MinuteMath number 103, and I think this is going to be the Mathematical Association of America's Minute Math problem for tomorrow, because this is a problem from the AMC 8 from 2005, and that's what they've been doing lately for Minute Math. Unfortunately, I'm going to be traveling tomorrow, so I can't do the Minute Math video with you, but I figured we'd just take a guess at what the problem would be and do it tonight. This problem is interesting because you've never seen a problem like this before. We haven't talked about this kind of geometry. But I think you might have some interesting ideas here. So let's talk about it anyway, even though you've never seen it before. In quadrilateral ABCD, sides AB and BC both have length 10. Sides CD and DA both have length 17. And angle ADC is 60 degrees. What is the length of the diagonal AC? Okay? Do you understand the problem?
Yeah.
Alright, what's a good first thing to do on any geometry problem?
Let's draw on what we know.
Draw on what we know. Okay. 10 and 10. Okay, so it says these two sides have length 10, these two sides have length 17, and this angle is 60 degrees, and we're trying to find this diagonal here. Okay?
Yeah.
Now, we haven't really talked about this kind of geometry before, but tell me, do you have any thoughts? Do you have any thoughts about this diagonal or anything in the picture?
Well, this line can't be greater than 20.
Why not?
Because if this triangle were all the way stretched out, it would be 20.
Okay, that's good. So the most this could be is 20. The most AC could be is 20 because these two sides have length 10. So if this was a math contest and like two of the choices were, let's say, 30 and 40, just for fun, you could eliminate those right away. Okay, good. Is there anything else you notice about this diagonal or anything in the triangles?
Well, this could be an isosceles triangle.
Oh, more than could be. What does an isosceles triangle mean?
It means that these are the same.
Not quite, actually. That's not what an isosceles triangle means. What does it mean when a triangle is isosceles?
It means these sides are the same.
It means two sides are the same. Okay? So an isosceles triangle has two sides that are the same. But what does it sure look like in an isosceles triangle is also true.
The two angles are the same.
That the two angles are the same. It does look like that.
But if the two angles are the same, then that means it's an equilateral triangle.
Well, let's not jump ahead. It is going to turn out to be true, and when we study this, it turns out that these angles are the same. So if I tell you, go ahead, these angles are the same, what's your next conclusion?
Well, that means that these are both 60.
Okay, back up a little. Why is that?
Because you already have 60 here.
Okay, so why are these forced to be 60?
Because they all add up to 180 and they're the same.
Okay, these all have to add up to 180, and these two angles have to be the same. This angle is 60 already, so that means these two angles have to add up to what?
Have to add up to 180?
No.
120.
120, and they're both the same. That means they're both 60. Okay, good job. Good job. So if all these angles are 60, how long is the line? Or the line segment AC?
Then it's going to have to be, what is it? It's 17.
Why?
Because all the sides are the same. It's equilateral.
It's an equilateral triangle. Hey. And hey, look, it's less than 20.
Just like we thought.
Just like we thought. Very good job, sweetie. Very good job. So these are the fun geometry problems we're going to get to probably in 2014, I bet. Probably in 2014. All right? Good job. Good job.